Bob is still in the hospital recovering from his battle with E3 deficiency in the PDC. He begins to get better and dreams of going back to his job as a stuntman. While he dreams of doing flips and backflips, the doctors notice that he is also presenting other symptoms. Bob has impaired coordination and difficulty seeing things in dark spaces. The doctors place a spaghetti taco at one end of the room and tell Bob to go fetch it. They realize that he has NARP syndrome when they see Bob having difficulty reaching for the taco. Poor Bob is going to have to postpone his dreams again until the doctors can get him better. But how do we fix Bob? First, we need to understand more about NARP syndrome. To do that, let's learn about ATP synthase. What is the ATP synthase complex and what does it do? Let's go into the cell and zoom into the mitochondria. But this time, we're going to focus on the mitochondrial membrane. ATP synthase is located in this inner mitochondrial membrane. Without ATP, Bob wouldn't be able to do his stunts or eat spaghetti tacos. And ATP synthase is important because it makes about 90% of your body's energy currency, ATP. Whoa. So what does ATP synthase look like and how does it work? Up close, ATP synthase is made up of two parts, an F1 sector and a membrane-embedded F0 sector. Protons will move from the intermembrane space to the matrix through the F0 sector. This causes the F0 to rotate, similar to how a water wheel rotates. The rotation of the F0 causes F1 to also rotate and change shape, allowing ATP to be made. Now let's see it in action. So what happens when ATP synthase breaks and why do we care? In our body, we have lots of machines that work to keep us alive. These machines often work like a lock and key. When the information that codes for ATP synthase is written with a typo, otherwise called a mutation, the shape of the lock can change so that the key no longer fits and ATP cannot be made. Because Bob is not able to produce as much ATP, he will feel very weak and tired. He will develop neuropathy, ataxia, and retinitis pigmentosa. This is also called NARP syndrome, and Bob got it due to a mutation in his mitochondrial MTATP6 gene. So back to Bob. The doctor informs Bob that there are tests that have been done on yeast to treat NARP syndrome, but unfortunately there are no human treatments yet. She will try to help Bob by treating the symptoms he faces due to NARP syndrome, and hopefully someday he can do his backflips again.